Welcome, everyone. Today, we're here to have a very special discussion. Most of you know me. I'm Michael Gibbs. I'm the founder and CEO of GoCloud Careers, and I'm here with my friend and colleague, David Linthicum. David is Deloitte's Chief Cloud Strategy Officer, or as he likes to refer, Chief Cloud Geek, and he's a wealth of knowledge. Both he and I together have more than 60 years experience in cloud, in networking, in AI, and we're going to have a real fun, highly productive discussion today. We're going to talk about multi-cloud architectures. We're going to talk about multi-cloud versus hybrid cloud. We'll talk about single cloud versus multi-cloud, and there's times where each are advantageous. We'll talk about hybrid clouds versus multi-cloud, hybrid multi-cloud. We'll even get into super cloud architecture. And of course, we'll cover the ending question, do we go private cloud, public cloud, or both? So what we're going to do is we're going to discuss cloud computing and various cloud architectures for a little bit. And then after that, we're going to answer your questions on other platforms. So I know you're awake, alert, and oriented. You know, I come from medicine, and in medicine, we want to know that everybody's there. Give me a hashtag cloud architecture, and that way I know you're awake. Also, if you want to let us know where you're from, let us know that in the chat box. It'd be either LinkedIn or Facebook or YouTube or wherever you may be, because we're everywhere today. I can tell you right now, I'm in South Florida, specifically in Port St. Lucie with my wife and my cat. And it's, it was a nice sunny day, but it started raining like it does every afternoon in South Florida. David, do you want to introduce yourself for a minute?
Sure. Dave Linthicum. You already mentioned I was this Chief Cloud Geek at Deloitte. Do a lot of this cloud architecture stuff, and doing it for a long time. Focus on complex distributed architectures and enterprise technology and how it works and plays well with the enterprise. I wrote 17 books, including the latest book behind me, which is called An Insider's Guide to Cloud Computing. I do the InfoWorld blog. I've been doing that cloud blog for about 12 years. Also do a podcast and do other blogs and do a lot of speaking events, and just really love talking about how cloud architecture works and how to succeed with it.
David's a great person to listen to. Go get his book. There's lots of lessons in there. When you do what we do for as long as we've done it, we can give you those insights that most people may never see, because both David and I have done these architectures that span the biggest companies in the world, and everything breaks when you get to scale. And that's really where you get to learn stuff. So the reason we're going into multi-cloud is we all started out, well, I like to say I started out with the single cloud.
Mike, you're going to make me buzz you already.
We're gonna have some fun. And the
I gotta buzz you. I got some things to tell people.
Oh, you got some things to say? Okay, go ahead and introduce them.
Yeah, I got my buzzer. All right. So I know Mike and David are excited to talk with everybody, but before I let them take over the show, I do want to make sure that everybody knows about our email mailing list so that you don't miss these types of things in the future. This week, we've got David. Last week, we had Dr. Johnson and Dr. Long from the University of Tennessee at Martin. And in the future, who knows who we're going to have, not only on Head in the Clouds, but anything that we might have. We might have a workshop, might have a boot camp, might have something special for you, a new guide, a new product, a new something. Or maybe we just want to reach out and say, hey, sign up for that email list. It's completely free to you. I just wanted to make sure everybody knew about that. Also, I'm going to be putting the link to David's LinkedIn profile on all the platforms. So I think we're on Facebook, we're on LinkedIn, we're on YouTube. So I'm going to get that link to his LinkedIn profile for all of you, as I'm pretty sure most of you are going to want to follow him, connect with him there. So be looking for that in your respective platforms. So that's all I've got. Alonzo, normally I would ask you if you want to say anything, but I'm pretty sure you're like me. You're ready to just sit back and hear what the conversation's going to be like.
Yeah, definitely. I definitely have to give the shout out to Dave Linthicum for coming and joining us today along with Mike Gibbs. I am so excited to do this. I'm excited to be here with these gentlemen and learn, you know, as being a follower and studier of cloud architecture and cloud computing as well. I mean, get a chance to sit down with the greats. That's all I have to say about that. So I got my my chair, I got my drink, I got my water. Let's get to it, gentlemen.
All right. So we're going to leave you all with Mike and David, and we might come back later on. Who knows?
I think we will. So I like to say those who do not remember the past are condemned to repeat it. You know, David and I worked on clouds 30 years ago. The first cloud I worked on was actually ISDN and frame relay. And in those days, what would happen is an organization, they would get a wide area network connection like a T1 to their cloud, and the service provider would create these virtual network links. And they worked great. And when I started, there weren't many people that were doing it. There was basically AT&T and WorldCom. And, you know, fierce competitors. And what WorldCom would do, and AT&T would also try to do, was say, we have separate networks. We're completely 100% fully redundant. We'll build you a private frame relay link. And if that fails, you have an ISDN backup, all on 2 separate clouds. We're completely diverse. And you know what happened? They'd have service provider outages, and both clouds would go down at the same time, and the customers had no service. So I started, it was a single cloud, you know, 1995, 1996 single cloud stuff. By 2000, everybody had an AT&T and a Verizon link. And that way, if the AT&T cloud went down, the Verizon cloud was up and running. Worked great. And we might even use a tertiary provider for backup. That was single cloud. Now, in those days, all the cloud was a network. David and I can tell you that those 56K lease lines between New York and, say, Delhi, India, were $5,000 a month for 56K. And then, out of nowhere, we had gigabit Ethernet and 10 gigabit Ethernet and 100 gigabit Ethernet links and faster. And now we can now put data centers and share them. And then the cloud computing of the I think it was around 2009, became the virtualized data center instead of the virtualized network. And almost like for everyone, we forgot that we needed 2 clouds. Everybody went to a single cloud, because at the time there was really only one. And everybody thought that the cloud providers were fully redundant, just use multiple availability zones, multiple regions, and nobody really thought about the cloud's control plane or the cloud's network or what would happen in a security event. They all went to one cloud, and then the cloud outages occurred. How many? In 2021, there was a cloud outage every 2 weeks that lasted at least 30 minutes or more amongst Google, Microsoft, and AWS. So, out of nowhere, now we're in the world of either hybrid cloud or multi-cloud. So I'll talk a little bit about what these architectures offer. Then we're going to go to SuperCloud, and then David and I are going to have a conversation about the complexities of multi-cloud. So the hybrid cloud, which is very simple, organization has their own data center or private cloud, and they have the cloud provider. Now, what's this good for? Well, generally speaking, it's cheaper in the data center than it is in the cloud, especially in today's world. Because there's no latency to the cloud provider, the performance is better. Because we can truly manage those networks, we can implement quality of service and other features we couldn't do in the public cloud, and we've got much better storage access in our local data center. So we've got better performance, generally lower cost, and if the data center fails, the cloud provider fails, guess what? We've got everything. We're still up and running. But data centers aren't very agile. Even when we put Nutanix or OpenStack software in it, which I love, they're not super agile. And the public clouds offer a level of agility that can increase the velocity that businesses change and can do things, which is worth so much, regardless of the cost. So then the idea is, what about 2 clouds? From an availability perspective, we use 2 clouds. One cloud fails, the other one's up. But some cloud providers have better features and functions than others too. And by leveraging one cloud, we can use, say, AWS for its infrastructure and maybe Microsoft or Google for its AI capabilities and still have a really wonderful agile solution. So, you know, that's why a lot of organizations are going multi-cloud, both from an availability perspective and to build the best of breed architecture. So, you know, whether it's a single cloud or multi-cloud, single clouds are the most agile. They're the most nimble. And for businesses that don't need 99.999+% availability or greater, that agility may be worth it. It may be simpler too. And that agility itself with one cloud versus many, again, could be worth something to the business. And I like to say architecture is just a series of trade-offs. So how do you feel about that statement, David?
I think it's absolutely right. I mean, ultimately, we take a look at the right configuration of technology, and you have to look at the risks and the values that are made from each of the configurations. You got to remember, there's probably 5 factorial of things that normally work in a particular architecture, permutations. And just because something works does not mean it's the optimal solution for what you're looking to bring. And so good architecture is about understanding where the business requirements are, understanding the state of technology, which technology is viable to leverage, and configuring it in such a way that it optimizes the value that's brought back to the business. And so people need to consider that. Just because your solution works does not mean it's optimal. It may work, but it could end up costing you $15-20 million more a month than you should be paying. So architecture is extremely important for people to do the pre-planning to make sure they're picking the right technology and the right configuration with the eye of the business in their heads.
And David, I love that. You just talked about something I talk about all the time. The business drives the architecture, not the technology.
That's right. Yeah, I mean, ultimately, if this is about you leveraging the architecture that the cool kids are leveraging, you're going to end up making mistakes. And certainly if you have an absolutist attitudes, in other words, you're cloud only, you're private cloud only, you're not doing any cloud. I hear that all the time. Or you're moving toward AI in an aggressive way and not necessarily looking at the right applications and use cases for the technology, you're going to end up with something that's going to be under optimized because you're not considering all options. And I understand that the technology moves, the tech press is kind of talking about different layers of technology. Certainly AI has a lot of momentum behind it right now, but we still need to look at this stuff in a pragmatic way to make sure we're picking the technology that's right for a particular use case. And I think that people have a tendency to lose sight of that. And that's because of the ease of use of technology. Cloud computing, you can provision at the speed of need. You can get things up and running fairly quick. So it doesn't take these long procurement cycles where you can, rethink some of your architectural decisions that are being made. And we can make mistakes much faster. We can also spend a lot of money much faster, and therefore we can do a lot of damage much faster. And so we need to quell our ability to leverage technology. I'm all for new technology, love the AI stuff, things like that, but make sure we put it in the proper perspective so how it can bring the most value back to the business. Not that we think, but it's provable with metrics. In other words, we can show the board of directors and show the executive team that this is a configuration we need to go for. We looked at this. We think it's optimized in these ways. We have these metrics. We think success looks like this, and we're able to prove it out, implement it, and therefore provide the most value back to the business. And by the way, we're freeing up resources that we're not spending on these overages within the company, that the company is able to invest in other things and being innovative and creating better customer experiences, things like that. So just making them a better company. It's not how much you can spend. It's how successful you are in bringing value back to the business.
Yeah, that's exactly true. And where so many people mix up cloud engineering versus cloud architecture is cloud engineering is focused on the technology. Cloud architecture is focused, where does the business want to go? How do the business processes work today? How do we want them to work in the future? What technologies can we architect now and deploy in the future to make the business operate the way we want it to? And, initially what it looked like is, because you and I have been through these architecture states. Initially, we were techies. And then we became more and more executive along the way until I actually learned more architecture by working as a management and strategy consultant than I actually learned when I worked in tech. How to really find out what needs.
Yeah, I couldn't agree more. I think ultimately this is really kind of how people mature through their career. If you look at it, the ability to kind of be an engineer and focus on a particular domain, such as data. I spent some time doing data engineering. I spent some time doing network engineering. I spent some time doing process engineering. And then ultimately your ability to step up to having general knowledge of all these various technologies and how they really fit together. And so that's why good cloud architects, and I talk about this in my book, are generalists. In other words, they know a lot about a lot of stuff, and they don't know the details about stuff. So they're not necessarily going to be an API engineer in doing AWS stuff, but they understand what the trade-offs are in leveraging this particular API over another and how to secure these various systems. And we don't have enough of those people roaming the earth. And I think that we're trying to build more. And I think maybe that's why we're talking today here and getting people interested in understanding that aspect of leveraging technology and understanding the configuration of technology in the proper way is really how we're going to benefit the business in most instances. I can go off and get a certification on a particular technology, on a particular cloud provider, and do very well and probably have a pretty good niche career in focusing on that. But the reality is, if we don't have this bigger understanding of what these architectures are and how to configure them correctly, we're not going to get to the state that we need to get to leverage this technology in a more effective way. And we saw this in 2022. We saw the big bills come in. So in other words, people were spending, and the best I can tell is probably 2.5 times the amount of money that we thought they're going to spend on cloud. Once they went through the pandemic, real rush to the cloud in the last 10 years and basically migrating things to cloud. the reality is there wasn't a lot of time and thought into what those solutions needed to be. So I view those things as self-inflicted wounds. If you look at really where their inefficiencies are, they were completely avoidable if they just put a little bit more planning into the cycles. And now people are coming back and retroactively trying to fix those things, and I applaud them for doing it. However, if you don't dig a hole, you're not going to have to, if you're in a hole, stop digging. And I think ultimately that's really kind of the core thing that we need to understand, that we're getting to a point where we know what the technology does. We know how to set the configurations in place. We know how to leverage some of the best practices out there. We can learn from the best people and replicate those things in your particular enterprise. I'm just amazed at how many mistakes and errors I see out there that are completely avoidable. And when you get right down to it, it was probably a lack of training, a lack of understanding of the various technologies, and really kind of the ability to manage by magazine and move after the particular trends, versus understanding what's going on in your own business. So that balance needs to occur. And I think we're getting back to that now. I think people have made those mistakes. They spent that money, and they understand that if we don't have those capabilities to make that happen, it's not something that's going to be viable to the business. We're getting to a point where the businesses are leveraging technologies or key innovative differentiators. And so they're providing better customer experiences and better products and services. So if we're unable to do that well, we're unable to automate the business well, and therefore we're unable to have a business. It's completely coupled. It's not something where it's just an operational expense as it was just a few years ago. Automation is becoming the business, the processes, the innovation needs, the products, the services, how customers deal with you, things like that. And if you don't have that nailed and you're not putting the planning and effort behind it, you're not getting to the point where you're going to have a successful business.
It's interesting, and I'll get back to the concept. When I train cloud architects, I get to almost MBA level depth. We get into process re-engineering, we get into the business architecture, we get into the focus, because without it, here, this is a cool tech. I love this tech. The tech vendor says this is how I should deploy it, but the tech vendors themselves don't say how to solve this business problem, how to solve this business problem, how do I make this business more efficient? How can I use this AI tool to make this prediction? How can I use this AI tool for this? It's like, here, it's great stuff. Just buy it. Just trust us. It's really good. And then I think we get into the world of technical debt. Maybe you want to explain technical debt.
Yeah, that means we're paying for mistakes that we made for whatever reason, either on purpose or by accident. So technical debt means that we've sacrificed efficiency, probably for speed at some point in time, to implement a particular solution that we believe was a business need at the time, or maybe was a mistake that we made at the time, where we have a bunch of technology that was implemented that's way under optimized, and that becomes a technical debt. So the amount of money between a completely optimized solution, which you did not implement, and an optimized and a under optimized solution, which you did implement, is really what technical debt is. And some people are racking up some big debts, talking about students' debt being high, but in many instances, they just move in very tactical ways and go ahead and build the technical debt up along the way, understanding that they're going to have to return and fix that at one particular time, but they never do. So they have inefficient databases. They have over-provisioned and inefficient processing systems. They have multi-clouds and hybrid clouds that they built that are just poorly designed because they felt they needed to expedite the implementation of these things. And therefore, they eliminated a good architecture they could have probably implemented. They just went through another 3-month process and spent a little bit more money. So this is really hindering companies, very much like student debt hinders people. Technical debt hinders businesses. And we have to either go back and fix these things, which I recommend that you do. Make sure you don't try to accumulate a lot of technical debt moving forward. You're going to get some. That's a way of processing, but it shouldn't be something that we accept. And then moving forward, we're able to move in a much more efficient way. So a lot of the older businesses that have been around for 100 years, they built up a tremendous amount of technical debt. In many instances, they're not going to have the money and time to revisit them. And what's going to happen in some of those markets, they're going to be disrupted. So they're going to have smaller businesses that are in the same markets they're in that are going to be more agile, more nimble, that don't have a lot of technical debt, really focus on the innovation and the use of their technology to build the value around the business, to turn the technology into what it is as a true force multiplier. And the older business is unable to keep up. They can't provide the same cost efficiencies. They can't provide the same price and performance. they're unable to perform in the market that the other disruptors are able to perform. That's going to normalize the market. They're going to end up going away. And we've seen some of this happen in the last 20 years. We're going to see a ton more that happens in the next 5 to 10 years, where suddenly these large brands just kind of disappear off the market. Well, that's because behind the scenes, a smaller disruptor has come up, is able to weaponize their technology to get into their business, do better, be able to provide more value at a cheaper price, because all the technical debt and all of the inefficiencies that you built into your automation of the system is limited to your ability to go off and take that part of the market. People are going to see that as a vulnerability, and they're going to push you out of the market. And we're going to see that over and over again. And I think that's okay. That's kind of the way business works. But the reality is, I hate to see it when we got ourselves in trouble, understanding that the trouble was there, and not revisiting the fixes and going back and optimizing the technology at a certain time before it becomes too late. In many instances, now is the time for these businesses to revisit their architecture, revisit some of the under optimization, revisit some of the technical debt that they built up, and take steps to fix it.
I completely agree with you. I remember initially it was, you've lived through it. It was hey, we know we should invest in technology. Then it was, our competitors are investing in technology, so we're going to too. Then it was, hey, technology is a competitive business advantage. Then it's, if we don't have technology, we're going to die. Now it's, whoever doesn't have the best technology, they're going to be pushed out of the market by those that do. And by best technology, I'm not talking about which is faster. I'm talking about which is more, which helps the business do what the business needs better, as opposed to any piece of technology itself.
Yeah, it's got to be something that's aligned to what the business does and has the ability to provide a better customer experience and a better product or a better service. Fundamentally, that's where we're building these systems to provide that capability. So everything should be, and if you look at what digital transformation is, it's the ability to transform the internal operations of a system, the technical configuration, into something that's going to be more aligned to make the business successful, typically aligning the IT better with the customers. And that ultimately is how we measure our success and our failure. It's not in our ability to leverage the coolest cloud gear and the coolest AI gear and things like that, getting these things up and running. That's all well and good, but chances are you're probably building technical debt up because you're not looking at the completely optimized solution. You're getting off and playing with technology. You're not maybe solving a problem, but you're over-solving and overspending on how that problem is going to be resolved. However, your ability to look at the efficiencies of the various system, point it at what the business does, and provide the core automations that are going to set your business apart from the other businesses out there. So that's why the major businesses out there that are successful, IT is strategic to their business. They have a seat on the board. They have a seat in the executive suite. They're not looked at as an operational expense. They're looked at within those organizations as an innovative advantage that they need to foster and promote. They get enough investment. They're able to get the best people. They're able to provide the best training. All these sorts of things really kind of come into play, where they build a culture around optimization, a culture around excellence, and how we're going to do architecture, how we're going to leverage technology in the most effective and efficient way. And right now, I think that's probably 3 to 5% of the businesses out there. Everybody else is in more of a reactive state. They're putting out fires. They consider IT as an operational expense. Those guys are spending way too much money. And by the way, what the heck is this cloud bill we got? It's out of sight. That's because a lot of the mistakes that were made over the last few years. And those are businesses that are typically going to be in trouble. So you got to have not only the ability and process to get in and fix these things, to make the optimization things, but the culture to really kind of make the questions and have an open and honest discussion about what's wrong and how we need to fix it. And I think these, companies that are very closed and very autocratic, where they don't typically allow dissent and people don't descend, are going to get in trouble the most. And so, this is not only about adopting best practices, taking all these classes and reading books and things like that and becoming a really good architect, but this is about changing the culture and the fact that we're going to focus on innovation and we're going to focus on excellence. And we're also going to have the ability to have productive conflict in the ranks. One of the things I tell people when I'm on a project is you're obligated to dissent. In other words, if you disagree with what I'm doing, either my technical solutions or my ideas, your attitude, and you're obligated to tell me that. And we need to have a culture of that innovation, that dissension, to kind of bring things into the next level. We don't seem to be getting that as much anymore. People are going along to get along. within these cultures, within these environments. And I think as leaderships, the leadership out there needs to foster, promote a very different culture, a culture of engineering, a culture of innovation, a culture of really kind of taking the business to the next level by understanding that our ability to fail and question things and the ability to improve things is really going to be our ability to innovate, which is really kind of comes back to the value of the business.
And going back to the business, it's been, and you mentioned something very critical before we get into SuperCloud, and it's how important IT is. They should be on the board. When I started, the CIO of then is much like today's architect. They were a half executive and a half technology professional. That's like today's cloud architect. Now, a good CEO is a business executive that understands technology and has a team of enterprise architects and other strategists that are those hybrid people, and they know how to communicate to the board. They know how to communicate to the CEO, and they can really act strategically for the company, and they're part of the strategic team. I've watched that change, which is kind of an interesting and exciting change. When I look at the way people went to the cloud, it almost reminded me of the way a startup would start. Here's the way a startup is. It's got one person. They do a little of everything the best they can. Then there's two people, and then they're both working at the speed of light. And then there's three people. And by the time they get to 4 or 5 people, it's like, okay, it's time to clean up. Otherwise, we're never going to scale. And I think that's where we're at here. So, David, I'd love you to talk about SuperCloud, because that's an emerging trend in cloud computing. Could you describe what it is and what it's going to offer organizations?
Yeah, sure. It's really kind of an advent of dealing with the complexity and heterogeneity of multi-cloud. So in other words, we saw the fact that we're putting out more than one cloud brand. So Microsoft, AWS, Google, maybe IBM, maybe Oracle. And therefore we had one of everything. We had 3 or 4 different security systems, 3 or 4 different databases, 3 or 4 different application development environments. By the way, that's minimum. Normally, you have more than that per cloud provider that are being implemented. So I'm being a little kind to them. Right. And so we end up moving from, say, 1,000 services under management with a single cloud deployment to 10,000 services under management in a multi-cloud deployment. Now, how do you operationalize that? You have to keep all those skills around, things like that. So the idea of SuperCloud, MetaCloud, whatever you want to call it, is an abstraction layer that sits above the various cloud providers that are out there. And by the way, edge computing systems, legacy systems are all inclusive of this, where you're picking one of everything. You're picking one security system that spans cloud providers, maybe 1 or 2 in some instances. You're picking one database that spans cloud providers, metadata management that spans cloud providers, governance systems that spans cloud providers and your on-premise systems. So therefore, we're trying to deal with a complexity angle by simplifying all these various systems through abstraction and automation. And that layer is where SuperCloud is. So it's physically something that may exist in a single or multiple cloud providers, by the way, but logically it exists above the cloud provider. So you're dealing with cross-platform, cross-cloud-based solutions, and we're trying to find single solutions that are able to solve problems that cross the cloud providers. And by the way, it's always going to be bespoke on your particular situation. I wish I could tell you that some cloud provider out there has a super cloud they can sell you. When I wrote about SuperCloud a few years ago, everybody told me that their technology was a SuperCloud. That's not true. SuperCloud is something that's going to be architected and built. So it's an architectural pattern. And by the way, it's an old architectural pattern. Mm-hmm. You probably remember this as well, that we're dealing with complex distributed system through abstraction and automation. That's something we just didn't come up with last year and call it SuperCloud. That's something that's been around for a long time. And we're just doing the same trick now. But the cool thing about now is we have better technology to provide us with different layers in that solution moving forward. So the idea is to make cloud cheaper, to make cloud easier to operate, to make cloud more secure, and really to remove a lot of the redundancy that is occurring right now in multi-cloud deployments to a point where people can't operationalize these systems. So I think the term SuperCloud sounds kind of silly in many instances, but what they're doing is just, I use the term MetaCloud, but what they're doing is just talking about an abstraction layer, an automation layer that sits above the various technology platforms, including public cloud providers, on-premise providers, edge computing, mobile computing systems, things like that. It's about doing more with much less, and doing more with, and by simplifying the complexity and making complex things simple. That's what SuperCloud's all about.
Love that. And actually, you mentioned something that I'll bring up. And for people that are newer to technology, here's how you stay current all the time. Build enormously good fundamentals. Because if you do, The virtual machine was really invented in the 1970s by IBM. It got perfected by VMware in 1999. AWS's EC2, Azure's VM, Google's Compute Engine instance is 1999 technology. Then we had the VLAN, the first virtualized LAN on a network switch. Now we've got virtualized networking in the cloud. In the cloud, you can get a private link. We used to have frame relay 30 years ago, basically the same technology. We had what's called the private VLAN, where we had 3 servers in the same VLAN that couldn't talk to each other. Now we have containers and container orchestration. All the technology really is new iterations of the old thing. Now we may change the name, they make it faster, but it's pretty much the same thing in the last couple of decades.
Yeah, you're absolutely right.
New either.
Excuse me?
When was the first? I was going to say AI is not new. When was the first AI system you worked on?
Yeah. When I was 17 years old. So, and I'm 62 now. So that was a while ago. And AI has been around since the 50s, even before I was born, and hopefully you were born. And so, but the reality is we build on technology patterns that are currently around. And so it's not necessarily going to be something that's completely new, even though it's sold as completely new. Cloud computing is about the ability to have things that we found in a data center, including storage of compute and databases, and provide them as a service using a multi-tenant architecture. But the patterns of technology are very much the same that have been around for a long period of time. That's why I tell people, don't be scared of the cloud, because there's nothing in the cloud that's really net new. It's looking at existing stuff that we would have to buy and deploy ourselves, and we're leveraging it as a utility or as a service. Same thing with AI-based systems. You look at some of the generative AI stuff built on the machine learning-based stuff that was built on the, some of the deep learning and AI-based system and the research that occurred over time. So it's always layers of stuff that builds upon layers of stuff that we kind of make the foundation on. And I think that's a good thing, because we never have to start from scratch as a technologist. We can always have foundational learning about where something came from and what exists and what patterns that we have already learned in the past and how they exist in the existing technologies. Containerization, well, that first started with distributed objects and J2E, from a while ago. And even before then, there were lots of papers on containerization and the ability to have different distributed systems, and federated containers were something I remember even from the 70s and 80s. And now we have instances where the technology is finally able to work. So one of the good things that's happening now, we're building on older stuff that typically didn't work very well. For example, we talk about SuperCloud and MetaCloud. That has to deal with data abstraction, the ability to take multiple physical databases, and even though they're physically distributed, make them appear as a single physical database just in middleware. Well, that technology has been around since the 90s. Yep. I wrote about it in my EAI book, but it didn't work very well. It was very slow. The mapping was very difficult to do, and if you had complex abstractions, it was basically a performance killer. Now that stuff works almost as well, even sometimes better than a physical database. So it's the fact of the matter, we're able to take the best of breed of technology that's really kind of had a history, maybe even failed at a particular time, and reinvent that with something that's going to be new, now with more viable technology. And what saved those things is the fact we're able to we have faster processors and faster IO and faster networks, all these sorts of things, which are really the killers. I mean, back then the whole AI thing was around. It had kind of a little mini revolution in the 80s when I got 84, 85, when I got out of college, working for Boeing Computer Services. We were building these systems, and they're amazing at what they could do, but they cost $50 million. Yeah. So how are you going to sell that to a business? So much of the capabilities that we're seeing today that we can use an on-demand system, probably we had a fraction of those capabilities cost $50 million to deploy, and a whole data center worth of storage systems and things like that wasn't viable. Not that the technology wasn't there. We know that the technology was valuable. We just had to catch up to providing the capabilities of this technology to work and play well in these environments. So cloud computing was like the perfect storm of that, because we're able to leverage a very expensive infrastructure as a service, and therefore we're able to use it for something that's almost free in many instances. And we're able to build upon the learning systems of the learning that we occurred over the last 30 years. So we're building on the engineering, and in many instances, the trial and errors of the engineers that worked back in the 80s and the 90s and 2000s to build up to what we have today. And people who, I love when you said, you're doomed to repeat it if you don't understand history. And the reality is we have to take those lessons learned and make sure that they're part of building these systems. As we're architecting these environments, understand that these are layers of technology and the patterns of use are going to be very similar. Like we talked about the SuperCloud Metacloud thing, that's a derivative of an architectural pattern that we used to deal with, at least I did in the 80s and the 90s, and still around today as we built these, large-scale distributed systems. When you look at what a multi-cloud is, all it is a complex, heterogeneous distributed system at the end of the day. It has new stuff. There's new ways to interface with it. It's much faster, and it's it's way cheaper, but the patterns are exactly the same. So we have to remember as architects that we can't lose sight of what worked in the past and bringing that forward into what's going to work now. And I think that's where a lot of the innovation is going to occur. The ability to kind of understand things that we succeeded with in the past, may have had a harder time with, and the ability to take it forward and look at it in the context of the new technology, in the context of cloud, and build net new, more innovative things that are going to be more valuable to the businesses.
It's funny. It was back in 2000. It was 2000, before September 11th. I had worked with one of the largest market makers on the NASDAQ. We spent about $150 million on our data centers. Big, high-speed data centers, big, giant Sun refrigerators everywhere, those Sun Microsystem servers. And I helped the chief technology officer give a presentation to the entire IT division. And I remember when the chief technology officer said, we have 3.8 terabytes of data. And here we are with a $150 million system. But you know what? Many of those architectural patterns that we used then, the way we clustered certain servers in the same rack for lower latency, some of the algorithms that we were using for program training, the way we built our systems, the disaster recovery systems, it's the same architectural patterns we use today. In fact, in some ways, they were actually ahead of the curve. We just had to make all these architectural decisions because we might have a router that had a 10 megahertz CPU and 16 megabytes of memory.
Yeah, we did things very efficiently when we had an 8K stack that we were dealing with. And so the resources were gold and you couldn't waste them. And so there was no, it's going to come out in the compiler. You had to figure out and engineer it and get to a more optimized solution just to kind of make it work. And I think that needs to be thought of today as we build some of these systems, trying to become more sustainable and more optimize everything we just talked about. You have to think in terms of how we're going to optimize the engineering of these systems. And the fact of the matter is we're not going to ever waste resources. We're going to build things more as efficient as we can. And even if they put a little bit more time in making that efficiency occur, it's going to pay off on the back end because we're going to have lower cloud bills and faster systems, more efficiency, and even get to sustainability. They're going to have a lower carbon footprint. They're going to burn less power. They're going to be more reliable. They're going to be more secure. All these different benefits that comes out of good architecture and good engineering, which we, really in some instances have lost sight of because we had to live in terms of a budget, whether it's a hardware budget, the money, or it's the actual stack that we had and the amount of storage that we had to leverage and build these applications on. Now that seems almost unlimited because we're able to make the cloud, but we still have to pay for them. And I think that, we need to highlight in terms of moving into an AI-enabled world, which definitely we're moving into, in one way or another, that these can't be resource hogs unto itself. I understand that we can access the stuff and we can allocate the resources, but the efficiency still needs to be there and how we're building and deploying these systems. And also we need to pick the proper use cases. We need to make sure that we're building something in such a way that's going to bring the maximum value to the business, to get back to the beginning of the conversation. And so in building these AI systems, it's incredibly, attractive to start leveraging this technology for all sorts of purposes, but it's not a good use case for business transactional systems. It's not a good use case where you not have to deal with data analytics and don't need inline AI-based systems and decision support. It's going to cost you more money to build those things. So you need to be careful in terms of how you use them. That doesn't mean don't use them. It's going to have great viability and the ability to bring huge amount of innovation back to the enterprise, but make sure we pick our battles with that technology. And that's the scary thing right now. I think it's almost like cloud back in 2009, 2010. People were like, well, cloud only, and they made a huge amount of mistakes and pushing lots of stuff to the cloud that didn't belong in the cloud. Now, in many instances, we're bringing them back on premise. And now I'm hearing AI only, and they're going to build every application with AI capabilities, when in many instances, it's not going to add the value. And a good architect is going to have to stand up and say, hey, we're not really thinking through this. There's no value here that I can find that's going to need to leverage this technology to change these various applications. We're going to, or even find a hybrid use of it, where we're AI enabling a part of it, but not the entire thing. Or we're not using all the information as training data. Also, how we pick storage and utilization. We're not replicating data just for training data. I find that's a big temptation right now, but we're leveraging the data where it exists, and therefore we have fewer storage and more optimized systems. So we need to make a lot of decisions at scale and provide more value back to the business and think in terms of the business. And I know people, you get a computer science degree, they don't teach you about business. You don't take a business class, things like that. But the reality is we have to be business leaders in computer science when it comes to architecture. We need to think about the viability of the business. We need to think about the technology. And we need to look at what businesses need to serve, the shareholders, and return and value to the investors. And that needs to be in every consideration, every decision that we make.
Apologies for that. My internet went out, and it took about 40 seconds for BGP to switch over to my other internet service provider.
I thought you're freezing on me to fake me out.
No, I have. It's like practically a hurricane outside my house right now, and my one AT&T line goes down a lot, but Verizon picks up pretty quickly thereafter. So, I totally agree with everything you've said there. So we're going to talk about multi-cloud. So could you talk a little bit about managing the complexity of multi-cloud? Because the numbers are somewhere between 90 and 98% of organizations that are now multi-cloud.
Yeah, anybody who has more than one cloud brand is a multi-cloud. And of course, the definition of multi-cloud is all over the place. So I would just say that you're managing more than a single major cloud brand, AWS and Microsoft, that qualifies you as a multi-cloud. But normally there's a private cloud there, there's edge computing there, there's internal on-premise infrastructure there. So it's normally someone that has a very complex distributed environment with multiple brands and multiple platforms. And that's what a multi-cloud is. And again, we've been dealing with this for many years. It's not just now.
No.
So when the ability, everybody is built upon that. You mentioned it earlier, and I thought it was spot on, best of breed technologies that they need to bring on board, leveraging whatever cloud they need to make that happen. That's how people typically get to multi-cloud. So I always tell people, if you don't move to multi-cloud in a planned way, it's going to happen to you, because different organizations for different reasons are going to pick different technologies. Those technologies are going to be on different cloud providers, and those cloud providers are going to be all over the place in terms of where they are. And so it may be, you may have Oracle just because they're leveraging the database on Oracle. You may have AWS just because they're leveraging the CPUs and the storage systems on AWS, and the same with Microsoft, things like that. So that's kind of what a multi-cloud is. And so different degrees. Normally there is a single cloud provider that provides at least 80% of those services, and the remainder provides 20%. The 80-20 rule typically provides, and that because that was their initial cloud provider, normally AWS or Microsoft, and then they got into Google and Oracle and things like that as needed, where they had systems that are going to be in there. Good news, bad news. The good news is we're giving people the ability to leverage whatever technology they need to build their systems. And I don't think it's good to put limitations on people, on developing teams. So I can't go to them and say, only use AWS, when they actually have a best of breed service that they need from Google or Microsoft. So it provides more efficiency. It provides more culture of innovation, the ability to get things out quicker and do all the things that you can do if you give people the freedom to pick the technology that they need. Bad news is something we already covered. It creates complexity. So complexity creates cost. It creates the fact we have to have different skills around. So instead of just AWS skills, you have to have Microsoft skills. We have to have Google skills, Oracle skills, whatever cloud that we adopt. And so I don't know if you've looked at budgets lately, but they normally don't like to expand them. And so in many instances, people haven't planned for the amount of skills they need and the amount of tooling that they need to support these multi-cloud deployments. And so what organizations are doing now is, number one, they're limiting the number of clouds they're going to use and normalizing their multi-cloud stuff. Again, there's a disadvantage in that, is you're not going to provide them the ability to leverage the best of breed technology they need to take the business to the next level. Or they're just underspending on operations and security and governance and all the things that really need to run their cloud providers, and they're raising risk. So in many instances, I'm seeing breaches that are occurring. You normally don't see these on the news cycle, but you do a postmortem and you figure out that it was a configuration problem. And a configuration problem because we had 15 different security systems now when we had 5 2 years ago. and we couldn't increase the number of people and the number of resources, and so we couldn't keep up, and therefore we misconfigured something, and a vulnerability was caused, and someone broke in and took our data, which could cause a collapse of a business in many instances.
Oh yeah.
So that's a payment of it. Operational outages that are occurring because we're not operating the system as a single unit as multiple platforms. We're operating them as individual silos, and in some instances, we're letting something go down. In other words, we don't have a BCDR backup recovery stuff because we don't have the bandwidth to think about stuff. So getting to the good news of multi-cloud provides choice. As one of my CIO friends says, it's an abundance of choice. Which is good, provides value to the business. Bad news is we're getting resources too stretched among various platforms. We need to think about a way to do it. And so we talked about SuperCloud and MetaCloud. That was a response to that. The ability to deal with complexity through abstraction and automation, the ability to put kind of an architectural framework around that. In the case of SuperCloud and MetaCloud, it's really a concept, not really a framework. And kind of understanding that we got to stop dealing with complexity on the terms of complexity. We have to start dealing with complexity on our terms. That means we're combining things together. We're leveraging a single security system that's able to operate across multiple clouds. Same with governance and same with database management. It can't be everything, by the way. And it's the system's never going to be something that's very clean. We're leveraging just a single security system, just a multi-factor authentication layer, just a governance layer across all platforms. It could be a few different products that we need to do it. That's what a good architecture is. It looks at the trade-off and making that happen, but it can't be separate silos for each particular platform that's out there. There has to be some commonality that occurs across the platforms. Yeah. And so multi-cloud, huge amount of advantages. By the way, it wasn't something I've ever recommended. It just happened. Yeah. But I knew it was coming because I saw people needing to the clouds were getting competitive. We had more than one cloud provider that was viable in the market. And so just ipso facto, we're going to have an organic growth and therefore the leveraging of more than one cloud brand within these environments. So we needed to figure out a way to make it happen. And that's, by the way, the biggest challenge right now for architects. It's not only figuring out how to manage these things in a better way through better architectural configuration, which needed to occur 5 years ago, but we need to go back and fix it. So in many instances, it's like changing tires on a truck that's going down the road. And so that's going to be a challenge for many instances. But if you look at good architects, it's the ability to kind of look at what those deficits are and put together a plan to make things a little better, a little better, a little better, a little better, a little better. Deal with security, deal with governance, deal with database management, maybe on 2 systems, not 3, and then ultimately combine these things together where we do have a common framework. So right now, it's important that architects understand they have to go out there and get the planning in place to make this happen. People need to understand that it's important. It's important for the business. It's important for the IT infrastructure. It's important for the success of the business moving forward. You need to get the funding that you need. And you need to put the planning in place to make incrementally better decisions, lots of battles that win the war that need to start occurring right now. And I'm seeing some of it. I'm just not seeing kind of a fire in the belly because I don't think people have put their hands on the burner yet. But I do see that's going to happen in 2024 and 2025. We're going to see huge deficiencies that are coming, huge limitations that are being built in their ability to scale the technology out because of these complexity issues, and therefore some architectural forethought that needs to go into fixing these issues ongoing.
Yeah, it's interesting. Everyone we've trained since our inception several years ago has always been multi-cloud. Because let's face it, multi-cloud's not new. We ran multiple data centers for the last 30 years. So it was like, well, this is standard. And we knew from an availability perspective, people would ultimately go some other solution for at least mission critical businesses. And we also knew best of breed. And, the cloud providers like to talk, sometimes you have to go lowest common denominator if it's a bad thing. But, if I have a choice of a Palo Alto firewall versus AWS WAF, I'm going to use a Palo Alto firewall. It's got more features and functionality anyway, and I'm going to deploy it across all my clouds. Maybe I use an Oracle database, and Oracle's been working on that database for 30 years, as opposed to one that's made on the cloud provider, and I can run that. Now, that's the easy part. Now, what about the orchestration of all this stuff? From an architecture perspective, it's easy. A virtual machine is just a virtual machine. A container is just a container. Block storage is block storage. But for the engineers that actually go build this stuff, they've actually got to get used to how do I do it on what? And what is the functional equivalent of what to what? Because, they're hands-on.
Yeah, it's got to be looking at the different trade-offs out there and looking at solutions that are going to span different platforms. Orchestration is a key one that you just mentioned. Your ability to kind of take all these various applications and all these data sets, even these AI-based systems that are existing now as silos, and provide connectivity and the ability to leverage them together as coordinated as to part of a business process to add value to the process. And quit trying to solve issues within the silo. In other words, just building a little application to solve a particular thing, and start looking at different abstraction layers and orchestration layers to remove a lot of the underlying complexity for making that happen. I think that's key. So your ability to not only expose the various systems through a common set of interfaces that are similar on each of the platforms, but your ability to bind those interfaces together using an orchestration layer, even building applications and building tool sets and tools on top of it. If you look at what SuperCloud, MetaCloud is at its essence, the ability to look at all these various, very different interfaces, put systems on top of it, such as orchestration, and therefore provide people with the ability to change things or put volatility into a single domain where you can change things through a configuration layer versus redevelopment and redeployment.
And we've seen a lot of migration towards that on the networking side, but networking always comes first because nothing works without the network. But yeah, and VMware has tried to do something like that with the VMware on the clouds. It's one user interface that you use for everything. But I think we need a really good orchestration layer that's very good for the clouds, that covers everything and kind of makes it easy.
Yeah, I don't think we have that yet. I mean, we have aspects of it. We, certainly have Kubernetes, and then with federated Kubernetes kind of being on the horizon. But as far as something that I can point to, that's the go-to solution, that's not going to be the case. I can always build an orchestration layer. I can bind these systems together using common container orchestration layers, but I actually may be making, in many instances, things more complex. This is where you kind of get at an architectural trade-off. In other words, am I going to make this more of a problem by building a solution that I think is going to be less of a problem? And you actually could be adding another application development layer and deployment layer on top of very complex systems, which makes things more complex. And you have to kind of consider that. We're trying to make things incrementally better. And in many instances, that technology is going to make things incrementally worse.
It's true. And something in cloud computing, because some of the cloud, most of the clouds are limited to, say, 1999 to 2001 networking, we have to do a lot of jury rigging, duct taping to kind of get some of this stuff to work in the cloud. And the jury rigging adds more complexity sometimes than we actually desire, but sometimes we need it. But yeah. Maybe you want to discuss infrastructure trends for a few minutes, and I have a feeling we've got a lot of questions waiting for us.
Oh, sure. So infrastructure transformation, your ability to kind of move from an on-premise infrastructure into a cloud-based infrastructure?
Infrastructure trends that you're seeing, maybe you're seeing some networking as a service for connectivity to the cloud as opposed to your traditional WANs or SD-WAN, for example. Maybe you can see there are other infrastructure trends that you're starting to see with different cloud providers.
Yeah, I'm definitely seeing network on demand, network as a service that's starting to occur. And lots of organizations out there very much like storage as a service and BCDR as a service and things that we typically would want to build in a data center. You can leverage aspects of that out of the existing cloud, certainly the management layers and the configuration layers. And in many instances, they support multi-cloud configurations. In other words, it's as a service, which is custom built to layer into a multi-cloud. Prismo is a good example of that. You can go out to Prismo.io and see what their solution is, but there's lots of solutions out there with the same sort of patterns. So the idea being that instead of building a physical network ourselves, we're going to leverage something that's going to be on demand. And I think in many instances, that's going to make sense because we don't have to own physical routers. We don't have to own distribution systems. We don't have to own operations in many instances, and we're going to make it easier and better. The trade-off would be is that we're putting our network, which you just mentioned is kind of the mother of all single points of failure, into the hands of another company, and therefore their existence and their ability to provide a quality service and provide an SLA, a service agreement among the various cloud providers is going to be key to success, which means that you may have a higher risk than putting it into, just AWS and just Microsoft and just Google. But something that really kind of spans networks. So what you want to look for there is, number one, your ability to support the various clouds you're looking to support. and someone that's going to have a trusted capability like you would with any other infrastructure. Normally, people don't cheap out when it comes to building network systems and even buying servers, because they understand it's going to be, if outages there are going to be killer for them. So you should think about that in the same pattern and leveraging infrastructure out of the cloud. And so whether it's networking services, database services, storage services, whatever, but when you're leveraging things you would normally find in a data center or buy components for a data center, those things should be first-rate quality, and they should live up to an SLA standard that is going to be very clear in terms of their ability to perform over time. And if they can't provide that capability, I would look for other vendors or even doing it yourself. So there's no reason that we can't look for more viable and better infrastructure that we own, basically, when we own the equipment, because the need there for an ultimate have a network that's completely under control that removes most of the risk, not all of it, or most of it, is going to be on our hands, and we may have to just buy stuff.
Yeah. And networking is not going anywhere. That's one thing that I can say. For people were thinking, oh, networking doesn't matter. Well, without the network, there's nothing. So, David,
I don't know who's saying networking doesn't matter.
It's funny. I saw some of the cloud people initially come out there. They were certified, but they didn't know cloud. And they were like, well, networking is a dead career. Well, no, it isn't. You can't have a cloud provider without a network. You can't reach the cloud provider without a network. You can't do anything without the network.
No, you can't do anything without the network.
You up to answering some questions with me? It looks like we've got a lot of them from the audience.
All right, cool.
Okay, so team, bring us some questions.
All right. I'm going to bring me and Alonzo back in here also. Not that I think we can answer these questions like you guys can, but I figured add some flair to the screen here. All right, so I'm going to go all the way back. I've been taking down timestamps for some of these questions. Actually, the first one's not a question. The first one's a comment, and I actually thought I liked the comment so much. It's from Igor talking about the message that you guys have. He says, it's weird. It's like listening to one person who changes their accent. You guys even use the same words. Igor's a great member of the community over there from Europe, and he knows a little bit about changing accents to fit wherever he is. So I thought that was a good comment there.
Very good.
I was thinking the same thing as I was listening to you guys. I was like, okay, two sides of the same coin.
Yeah.
All right. So our first question is actually from Anna. Anna says, what do big companies usually do once they notice they're at risk? This came in about the time that you guys were talking about realizing that you had put things in the wrong place. You had taken on too much technical debt, and you basically, I guess, in this sense, like a financial risk of we did it wrong.
Yeah, normally it's the firing of the CIO, which when I see that happen, normally I realize the board of director found out about the technical debt. We're going to see more of this coming up. I just blogged about this morning in Infoworld.com. A lot of the FinOps systems that we're building are going to be able to examine existing deployments and look at them relative to their peers and other architectures and discover and identify technical debt, even strategic debts. In other words, not just cost savings, but the fact of the matter is that we messed around with technology we shouldn't have been messing around with, and that strategically hurt the business. And that's going to reflect back on people who made those decisions.
Oh, boy.
So, yeah, I think I think if they take it seriously, it's going to be, probably new leadership in IT and coming in and bringing in consultants to redo and restructure IT in a much more better way. And you don't hear about that. That's something they don't do a press release for.
No.
Suddenly there'll be some people disappearing and people switching off behind the scenes, and you can find out on LinkedIn who's coming and going, and just to kind of make that determination. But the reality is, like, boards of directors understand that this is a company killer, and it's no longer just an annoyance as it was, 15, 20 years ago. Now it's something that can take your company down in a very short period of time, because now we're investing in keeping a bad architecture and a bad technology configuration running, which is going to cost us way more money than if it was more optimized. And that's going to remove money from the business to take innovation to the next level. What do you think, Mike?
Yeah, I completely agree with you. Typically, what we'll see is a CIO that leaves for family reasons, and then they're there. Where I actually think this comes from, I see a lot of people that like to put serverless advocate on their LinkedIn profile or cloud advocate or something. I think you need to be a customer advocate. What is it that makes that client's business most successful? I don't care about what the technology is personally. I care about making my clients successful. So for me, and I'm sure for you, we start with client success and then figure out the stuff that we need. Cloud, non-cloud, I don't care. Whatever makes my customer successful, that's my favorite tool of success. So that's what I actually think.
Yeah, anybody's an advocate for it. We talked about that as an extremist with technology and pre-picks technology just because they like it. Is someone who's just going to make serial bad decisions, because that means you're going to be inefficient and under optimize a good majority of the time if you're just going one particular direction. You're not considering what the business is. And unfortunately, we have a lot of those people out there. Cloud only, no cloud, serverless only, containers only, and it just keeps going on. There's never an only situation. There's a it depends, which is what people hate to hear because it's a more harder problem to solve. But that's really kind of the question that needs to be asked.
We say it depends. That's about 90% of our starting answer on the questions that we get.
Well, it's right. It's the right answer, and I think that I understand people are frustrated with it. It's better if I were able to come up with an answer that's going to leverage the tech. But that's the answer I think people need to hear. How many people come up to me at conferences and always ask the same question: "What's the best cloud?" So it's like,
right.
Okay, that's never going to be an answer that they can talk about. It's going to be an it depends. You can certainly write an article and talk about the different trade-offs and maybe doing storage better and security better and things like that, which is probably going to be a book unto itself. But the reality is it depends on your own problem domain and your ability to back the appropriate technologies into your problem domain. So that's going to be an it depends.
You brought up back to the question here. You said something. I want to make sure it doesn't get buried in the response here because it was very appropriate. So obviously heads will roll, so to speak, when there's big enough mistake. But then they're gonna bring in people from the outside, most likely. They're gonna bring in, like you said, consultants to tear it down and make sure it's right. Because in a lot of these situations, it's not just the people at the top; it's ingrained all the way down through in a lot of situations. And so I just you mentioned that they'll bring that. Consultants will be brought in to assess the situation and take it from there. But that I just wanted to kind of circle back to that it's not just the action of, all right, CIO's gone. Okay, now we bring in this team to solve the problem or address the situation.
Yeah, CIOs normally never make decisions, certainly about technology unilaterally. So in other words, they're getting recommendations from their reports. And in many instances, that's the source of the trouble. That doesn't mean the CIOs are going to save their jobs because ultimately it was their call that made the decision to move in this direction or not. They didn't ask the questions that needed to be asked. But there is going to be a systemic cultural issue that has to be addressed for whatever reason they made these mistakes. And when you get right down to it, it may not be lack of talent. It's just lack of a culture for having people, as we mentioned at the beginning of the presentation, who aren't descending, they're not disagreeing, they're not questioning, they're not testing these things which need to be tested. And that's kind of fundamental to doing these things right. Architects should never be offended when someone challenges them. They should look at it as an opportunity to make their thinking better. And for some reason, that's gone out the window. In these organizations, you would think they'd be less autocratic in more modern states since we're more flat as an organization and everybody's working remote, things like that. But they're in many instances more autocratic and people aren't questioning people who need to be questioned. And so you kind of have to ask the question why that didn't happen. Why didn't people question the reports? Why didn't people ask the descending questions, make it happen? Maybe, and they're going to probably tell you that, well, if I felt I questioned my boss, that would hurt my career. I wouldn't get a promotion, I would get more money, things like that. Well, if that's the case, you have some bigger issues to solve. You have a cultural issue that needs to be completely revamped. And that's a harder problem to solve. But it's something that has to be addressed before you can actually make some of these systemic changes.
I guess I'm going to go two places. One is I've always figured that an architect that designs something themselves is the worst architect, because they should be talking to somebody from the application side, the database side, the data side, the network side, the security side, and really get it and get everybody's insight. And I've also found that a manager, whether they be a CIO or a CEO that people just say yes to, that's a person that's going to succeed. You can ask my team. I try to hire people that are at least as smart as me, and I want honesty. And Alonzo, how often do you or Chris give me honesty?
100%.
I'm sitting here wondering if what it would be like if me and Alonzo and Chow and Leo just said okay to everything.
Oh,
I'd be concerned. I'd be calling people and saying, okay, we got a problem here. Why am I this smart? Because I'm not that smart. Why can I do everything and is it always perfect? Please help me out here. Tell me what I'm doing wrong.
Yeah, and it works the reverse way as well.
Yep.
As the superior or the higher up don't know the role reversal as well. Don't just accept whatever your subordinate is bringing to you.
No.
Question it as well. It's a two-way street.
Yeah, it's a two-way street. I just want to highlight some wisdom, Mike. Just when I build an architecture team, kind of a dream team, I always have a networking person. I always have a security person. I always have a database person. I always have an infrastructure person. I always have, maybe a FinOps person. Different talents that are brought together to really kind of make the questions. Because guess what? I don't know everything about networking. I don't know everything about databases. I don't know everything about security. And someone who really kind of focuses on that as their area of discipline is going to ask some questions that are going to make the architecture and make my decisions better. I don't know how many times I've changed my mind on building an architecture and done a reconfiguration because of some of these questions that came up, that were brought up, that were legitimate, because I was going to run into a problem where I was going to limit the ability for that thing to grow into the future because I missed this particular detail that they were able to provide. So by all means, make sure that you build your dream team with a multitude of talents, but everybody's committed to making a common decision and a common framework of technology that's going to bring, again, more value back to the business.
Yeah, and you highlighted something else that was so important, David. I met some person one time that said, I only want to hire architects that come from a software development background. And I said, then you're always going to fail. He wasn't very happy with me, but it was reality. Software development is important. It's important to have somebody with that background. It's also important to have that networking background and the security background and the compute background, because if you don't, and you only know one thing, everything falls apart.
Yeah, the best architects that I work with today, they all came from a software development background. They know how to code, and I think it's kind of a basic understanding. That doesn't mean you're not going to round yourself out with different networking skills and security skills and things like that. But fundamental to building applications is really kind of fundamental what gets into architecture. Because as you build applications, your thinking has to be the different trade-offs that you make, different decisions that you make, and how you architect and engineer the system. I think once people have their brains wired that way, they have a tendency to be better architects.
All right. So let's look at this next question. So Riyadh asked, how do large consulting firms approach the design of highly effective and efficient cloud architectures for large clients? And what are their primary focus areas to ensure success in such endeavors? That's the grand question, isn't it?
That's pretty much all encompassing.
Yes.
Yeah, I think that consulting firms, and I'm going to answer this in a general way, typically have a couple of things that provide them advantages. Number one, they have they have exposure to multiple domains. In other words, they worked with lots of different clients and lots of different problems that they solved, and so therefore they've seen lots more good architectures and bad architectures, and they can put all those things in a context. That's the first thing. The other thing is they normally have some sort of a framework of understanding. And so it's the methodology thing again, but the ability to kind of make sure you have the checklists. And I view frameworks and these things as basically checklists to make sure that we're going through the diligence and all the things we need to go through. We're going through networking and databases, things like that. We're thinking about everything. I don't know how many times I've audited an architecture at the end and they're missing 5 of those just because they didn't have a checklist. Almost like if you're airline pilots, they go through these checklists every time, even though they've flown the plane thousands of times, they still go through it because it's important to make sure that we get all these things, that various components that are right, and we're making sure we tick them off. So that would be an advantage of doing that as well. And then let's see, what's the other primary focus on areas to ensure such endeavors? Well, the focus surely should be on the business, as we mentioned earlier. So we figured that this is about bringing value back to the business, and good consultants are able to basically trace this back to what it means to the business. And in many instances, people who are overly technical don't, but people who are spot on architects really kind of understand that that's the question they need to answer. What do you think, Mike?
Yeah, I think starting and doing things in a repeatable manner is what makes consulting companies good. And, I use the TOGAF framework with my students, and I like to say when I practice medicine, I used to do orthopedics. So I'd start with the feet and work my way up to the head. My wife practiced internal medicine. She started with the head and worked her way to the feet. Well, if we got to we'd ultimately get to the same diagnosis, but we did it a different way. And when everybody does things in a standard method, they start, with the vision of the business. Then they go see how the business works, and they figure out what they want to go to. At least if they use some methodology, they're more consistent. So that to me is the key: is start with the business and use a consistent model every single time. Look, I don't believe anybody's going to learn how to be an architect by learning Zachman's framework or TOGAF's framework. But if you are an architect, it gives you a great methodology to do it. Same thing for program management. Same thing for change management. Using an established framework and check sure prevents errors.
Yeah, spot on.
All right. So I want to let everybody know we're going to try and get through all your questions as best we can. If we can't, we can't. We're only human. So let's go on to our next one here from Steve. Well, where did it go? It was here. I will find it. Yeah, 235. Okay, from Steve. Does a supercloud utilize multi-clouds simultaneously?
Yeah, that's why we're building it. I guess utilize multi-cloud simultaneously would mean plural multi-clouds, which would just be a complex multi-cloud, if I understand your question. But the reality is if it leverages cloud simultaneously, that's where we're building it, because all these various siloed security and databases, things like that, we're using a common abstraction and automation layer to deal with them, rather than dealing with them using whatever native proprietary interfaces the cloud provider is providing. You're dealing with simultaneous multi-clouds. Maybe you're dealing with a company that may have divisions all over the place and they're running multiple clouds. That's more of an architectural challenge, because you're dealing with more complexity in dealing with those systems, but you should look at the same sort of paradigm to address the complexity. And so in other words, we're going to leverage common frameworks for a single multi-cloud domain. And if we own different multi-cloud domains, we're going to try to combine them into a single cloud framework, which is going to be bigger multi-cloud, which we're leveraging using the same mechanisms.
Definitely. All right. Next one. I'm pretty sure we're going to let David take this one as well. From James. What is an AI solution architect?
AI solutions architect is someone who understands a business process and how AI can be applied or not applied into solving that problem. So and by the way, when I hear solutions architect and I hear AI, that means we're pre-proposing the use of AI. So I kind of have a problem with that. However, I understand that there's certain solutions architects that may come into play when they've decided that AI should be leveraged in this particular situation. Then they would be someone who has domain expertise around AI and perhaps a few AI-based systems, who could tell you how to take your business problem that you've identified as needing to use AI and be applied to the AI space and do so correctly with the correct technology. So they would provide the domain expertise in AI systems, but again, once you pick that AI is the way to go. So the mistakes that I see made out there is people will call an AI solutions architect to do their architecture, all their architecture, and that's normally not the way it goes. You leverage them after someone has picked that is a particular direction, which is going to be optimized for that. And now we have the expertise to build the AI system, and that's what a solution architect should do.
Yeah, and I'm going to add to that. I'm going to remove the word solution. I'm going to go straight to AI architect, because solution could be anything. If you're at NVIDIA, a solution architect is selling GPUs or data center sort of stuff. If it's at AWS, they're designing and selling just AWS stuff. Well, at least that's their job, but then they'll be dealing with other people's stuff. So an AI architect is going to do exactly what someone said. Look at the business processes, the business challenges, and design AI solutions for them. So 100% agree. I just hate the word solution too, for that reason.
I think James saw that on a job posting. He wants to figure out why or
not. He sure did.
Yeah.
My best friend growing up was a solution architect at Sherwin-Williams for about 6 years there in high school and college. And so his was carpet, flooring, and paint. That was his solutions architect role.
Okay.
So let's see. Steve's got another one. All right. Is a super cloud just an abstraction layer that sits on top of multiple cloud environments, effectively pooling their resources? If so, does that make it potentially a single point of failure?
Yeah, it doesn't pool resources, it abstracts resources. So pooling resources would mean we're taking resources, we're putting them together in the same logical grouping. The resources really don't change. They function as they normally would function. So there's compute and storage and things like that. We're just interacting with them and managing them and operating them in a different way with a single environment on top of it. So it's not necessarily just on multi-clouds. A lot of people, push away on-premise systems and edge computing. I kind of include that into the solution because you're solving the problem. You might as well solve it for all the systems that are under your management. So they would be included in that particular domain as well. So and as far as it being a potential single point of failure, not really, because the systems are going to run whether the super cloud exists or not, and whether it's functioning or not for a certain amount of time. We have the inability to operate it and the ability to maybe not to see the observability of the system and maintain it in an optimal way. But the underlying systems won't stop functioning if the super cloud ceases to exist, if that particular system that's supporting the super cloud tool, stack, goes down. So I'm not overly worried about that.
Yeah, and I'm in the same position. It's if you've got an abstraction layer, it's not the stuff that's actually running, it's more of the orchestration.
It's the way you see it.
All right. Let's see here from where did it go? Telvon says, how would you both suggest someone build a great tech foundation?
You want to take that, Mike?
Yes, absolutely. So Telvon, we have to look at first we're going to assume you're the Telvon that I know to be a cloud architect, because you're going to need a different foundation for every career that you desire. But if it's for a cloud architect, you have to realize what you're dealing with. Somebody else's network and data center, which means you must learn the network and the data center. And that means the networking, it means the main protocols in networking, it means what is the virtual machine, how do virtual machines operate, same things with containers, same things with container orchestration, same thing with your storage area and networks, block storage, object storage, file storage, same thing with your business applications and what they are and how do they help for the business. And then the same things for your security, whether they be firewalls, IDS, IPS systems, VPN concentrators, next generation firewalls, identity access management systems, Telvon. They're not new. They're the same things we've been working on for 20 years. And I'll tell you where, in my experience, where people fail is they just learn, how to configure it, but they don't learn how it works. And you can't design what you don't understand.
Yeah, so I love that answer. Sorry, go ahead, Mike.
So Telvon, what I was going to say, and then I want to turn it over to David. You said great tech foundation. Remember, we're talking architects because you said, yes, it's me in the chat box that you are the architect student. Architect is half business. And even if you learn the tech, if you don't learn the business, you're not going to be able to optimize the business in any other way. David, do you want to go there?
Yeah, I was going to say your answer was perfect. And I was just going to say what he said.
There we go. Two sides of the same coin again.
Yeah.
All right.
Yeah.
You can't be wrong with those.
All right. Okay. Let's see. All right, Steve, you're keeping me on point here with all these questions, Steve. How about this use case for AI and SuperCloud? we may not be able to do this one or not. I'm not sure, but algorithms can monitor resource utilization and pricing changes, automatically making adjustments to minimize costs. Possible or being done?
Yeah, FinOps systems are moving quickly into AI-based systems, which are really going to be part of a super cloud. They're able to monitor availability, basically utilization of systems and how much you're spending, and they can find least cost providers, whether you're storage or compute, things like that, with a brokering arrangement. So that's going to be baked into FinOps, is going to be baked into AI Ops. Name of the name AI Ops would be part of it, where your algorithms are actually operating your systems, which are living in a super cloud. AI Ops, where it's really kind of custom built or purpose built for super clouds. So any number of systems, basically everybody is adopting AI capabilities and AI features into their software stack. That's going to be part of the super cloud. So it's going to be in there whether you like it or not. And you should like it because it is going to provide some additional functionality. And certainly FinOps is going to be the biggest automation system that's able to provide the best prices, provide the automatic brokering, provide accountability and resource utilization, observability, things like that.
Yeah, and I 100% agree with David. The only thing that I like to caution is FinOps is not a substitution to architecture. The right architecture prevents the problems in the first place. FinOps is like what a doctor does after somebody is sick to fix them. But it's better to prevent it and not get sick in the first place.
Spot on.
All right. Okay, so we got one from Valerie here. So will tools like OpenShift that are built on Kubernetes be great for SuperCloud?
I'll take that. Yeah, if you look at federated Kubernetes, OpenShift is the only technology right now that pretty federated container orchestration that runs across cloud providers, so AWS, Microsoft, Google, and other cloud providers. So if you're looking at an application deployment and development layer, they would be a contender for existing in a super cloud layer, an application layer that operates in between the various cloud providers. So that's where it would fit. I urge you with just kind of make sure that you're not considering that unless there's a reason to use it. And so in other words, it has to fit in a larger architectural framework. At the end of the day, it's application development and deployment, in this case using containers, in this case using federated containers. It would be existing in a super cloud layer because we're operating across different cloud providers, but it is a particular technology. So you'd have to make sure that that technology fits the needs of what you're looking for that technology to do, not just the fact that it operates in a super cloud.
All right. Oh, another good one from Igor. Igor says, can you tell us what specific skills we should gain to be the most valuable for employers and business?
What do you think, Mike?
I was going to say we go with David first, because I know we hear from Mike every day.
We'll both answer it.
Yeah, well, yeah, I want to hear from both of you, but I figure we let David go first because everybody hears from you all day long, Mike.
Yeah, right now it's the couple of the sweet spots would be number one, architect. They're scarce as hen's teeth. The good ones out there, they're very difficult to find, and they pay well. Probably data scientists would be number two, as far as people who are more valuable to employers, and obviously with AI capabilities, your ability to look in that. So I would look at data scientist skills. I would look at I would look at architecture skills, and certainly inclusive of cloud architecture, but don't just sell yourself as a cloud architect. It's architecture. You're dealing with enterprise-based systems inclusive of cloud, not just cloud-based systems. If you're looking at data science, you're dealing with the concept of data science and how AI-based works with those systems. You look at training data, all that stuff in terms of how it works, if you're going to be a data scientist. And then number three would be someone who is dealing with as a security architect. So in other words, we talked about the specialized skills that are part of an architect team. Security architects out there get paid very well. It's a very satisfying career. It's a nice specialist to have. They normally work with architects, but they're there to kind of bring the solutions up. They're going to be more viable around the architectural solution that an architect's working on. So they would be part of the team, typically not the entire team, but they would be in charge of dealing with the security solutions there. So that would be my top three.
And Igor, I'd say the same thing. I'd say that cloud architecture, but I'm going to put a / enterprise architecture in there because like David said, it's not just cloud. A really great cloud architect should be able to design a data center or a cloud. At the same time, I completely agree with that AI architect / data science, and I completely agree with the security. Now, you actually asked skills. So By skills, I think, we have to divide them between the business skills and the technology skills. I think David would agree with me, but I'll ask him. I don't think you can be an architect without presentation skills, without sales skills, without stakeholder management skills, without negotiation skills, without leadership skills, and without high levels of emotional intelligence and a degree of business acumen.
Yeah, I completely agree with that. And if you look at it, I'm dyslexic and didn't communicate well when I first started my career. I just had to figure out how to do that better because I realized it was part of my success as being an architect was be able to communicate to a business and communicate to an audience like we're doing right now. So those are skills that are going to be valuable no matter what career that you have, but that it's especially important when you deal with architecture. With problem solving skills, you're dealing with interpersonal skills, you're dealing with communication skills. And the big thing, you're dealing with business skills to the point that Mike just made. So you understand what the value to business means. You're not just focused on technology. Nothing frustrates me more when I'm dealing with a technical person where they're just seeing technology. They're not seeing how this applies to the particular business. That's not going to help anybody.
That's why a lot of times I retrain great engineers to become architects, because the engineers are working on the tech that's in front of them and they're building it. And the architects, the last part of it is we're not really touching it. You're not going to find the architects at a consulting firm build it. There's another team that builds it. Same thing for a cloud provider. So the key is we need to know how those things work. How does that database work under the hood? How does that virtual machine under the hood? How does BGP route its information? So for us, Igor, it's the understanding of how thing works and how to put them together, not necessarily how to build them.
All right. Let's see. So we've got one from Harsha here. Also, Harsha, I need to talk with you. Calling you out like that. I got to talk with you about
something. Like a request to the principal's office.
It's in a good way, Harsha.
It's a good way. If that's the Harsha I think it is, I'm pretty sure that is. I got to talk with you. It's good. It's good. Yep, that's the Harsha I think
that's
it is.
Harsha. Yep.
All right. Send me a message on Slack, Harsha. Before I forget, I'm turning into Mike. I'm not going to remember. Harsha says, what are some of the key evaluation steps that organizations need to ensure during multi-cloud journey?
I think the big evaluation thing would be the metrics around value that comes back to the business. And you need to figure out metrics to make that happen. So how do you declare it a success? So there's a reason that we moved to a multi-cloud, and that's because we're leveraging best-of-breed technology that we're unable to find in a single cloud provider. And so if we're going to do that, we have to be able to prove that the value is coming back to the business. So we're using this particular database that's on Google versus AWS, which is a primary cloud vendor. Why are we doing that? And what value can we present back to the business for the reasons of making that happen? Because that's going to add more complexity, more cost, and more risk to making that occur. So all of those metrics need to be considered. And you're typically in a multi-cloud, you may have 20 or 30 of those that you're considering. So why are we leveraging this, and what the viability for doing it? In many instances, I'm finding that there may not be a good business reason for doing that. It may have been a bias reason. In other words, I've used Oracle in my past career, and therefore I want to use it now. Even though it may not be a good reason to use it, there not be a viable requirement for making that happen. So that should be found. But if you're going to leverage a best-of-breed technology, there has to be, and I would put this on the people who are making that play, what value is this bringing back to the business, and be able to define it in core metrics and be able to evaluate it in context of everything else just being done. I know people don't want to do that. It's a bummer to hear that, but you're spending millions of dollars on this particular technology. You're adding more risk, you're adding more cost. So there has to be a viable business advantage for making that happen. How do you declare success?
And I'm with David 100% of the time. Should we or should we not? It all depends. There are also some times where we need the availability that can't be done on a single cloud. We may have a healthcare organization where if they only had a single cloud and it went down, people could die. We could have a bank who 1 minute of downtime is worth $3 million, so they may want to replicate a certain set of systems in two positions. Or it might be because, Microsoft's got some really great AI. And Google's got some really great AI too, and AWS has some really great infrastructure, and why not leverage all three?
All right. Richard asked, in light of all the latest ransomware and breaches that often occurred in data centers, what is your best value proposition for the cloud when talking to clients? Richard, you're trying to get everyone's secret sauce here.
Well, I mean, ransomware, by the way, can occur in the cloud. It's not immune from ransomware attacks. The problem with the data center stuff is people have a tendency to leave vulnerabilities in place, and in some instances are not backing things up. That's why they pay ransomware, because they didn't do the normal BCDR stuff, and they don't have current backups of the situation, things like that. So that's really kind of a self-inflicted wound. And I just wanted to make sure it's not limited just to data centers, even though those are often common attack, because they're often vulnerable because they're not investing the time and energy in making these things more safe. They're not backing things up. They're not putting in state-of-the-art security systems. They're exploiting those vulnerabilities, and therefore they get ransomware attacked. So normally if a ransomware attack occurs and you're damaged by it, that's normally on the business. That's a limitation that you built into the architecture, something you're not doing right, that made that have a negative effect, because in most instances, ransomware attacks are removed fairly quickly and the data is returned back to the state is. It may, cause you some consternation, but it shouldn't cost you a lot of money. But in many cases, people aren't doing the right things to making it happen. You just remember, in the cloud, you're still responsible for those systems. Those things can still be hacked. They still can be breached. There's a shared responsibility model. They're happy to quick to tell you. And so you're not immune from ransomware attacks in the cloud. Keep that in mind.
Yeah, but Richard, I think when we look at the cloud, we should think about agility. That's its primary benefit. And it's near unlimited scalability. So the key is, what does the business need? And always go back to business, and then figure out what the best tool for the job is.
Yep.
Okay. From Anakin, earlier you mentioned productive conflict and your teams having an obligation to dissent with you. How do you get to a culture where that's encouraged and not have people have bruised egos?
Well, number one, be able to take criticism without having a bruised ego. So getting to a culture that's, something that basically you have to turn and design yourself. So hire people that have that attitude, train people to have that attitude, and then promote a culture of that within the organizations. And some organizations have successfully done it. And so everybody's a little too sensitive these days, as I found out. And if you're a leader in these organizations, you should be able to accept criticism and understand the productive use of that criticism. It's funny, I got a email this week where someone was basically telling me everything they thought I could have done better in a course I just published on LinkedIn Learning, and I took it as productive criticism. Guess what? Next time I do a version of that course, all that stuff's going to be incorporated into that. And some of the stuff I didn't agree with, some of the stuff I did, but I'm not going to have a bruised ego from that. That person is doing that out of kindness, not necessarily out of meanness. And so I think people need to kind of accept that. So cultural transformation is something that's very difficult for organizations to do, but it's got to be in there, because unless you have this ability to descend, ask questions, to iterate through things, and also admit that you're wrong and go back and start from the beginning, in many instances, you're not going to be successful. You're just going to make serial number of mistakes. They're going to get the business in trouble, and you're not going to get a lot of value coming back. And so you may go home and feel you have a high ego because someone criticized you today, but you're also unsuccessful at what you're doing as an architect.
100% there. But Anakin, a lot of it also comes down to the emotional intelligence and the communication skills of the team. It's one thing to provide constructive feedback and or ask questions in a manner that's going to be heard. It's another thing to do it in a manner that's going to cause animosity. Chris gives me feedback every day. Now, I could literally wake up at 3:00 in the morning, come up with an idea, and text Chris in the middle of a dream. And it could be a ridiculous thing, but he's not going to say, Mike, you're an idiot. He's going to say, Mike, this is not one of your better ideas. And, that's the key. I'm willing to listen to it because of that. So all this is about finesse.
Yeah, don't start your criticism with "you idiot."
Yeah,
I like the word
Remember.
finesse. I like the word finesse. That is very appropriate. All right. Okay. So I do want to reiterate, we have a lot of questions, so we're going to get through as many of them as we can. We do have I believe we've got a hard stop at 4. So just wanted to set that expectation here for everybody. So let's go to the next one. My question is for David. With the wealth of knowledge and experience that you have, do you think it is possible for someone to be trained to be hireable to work as a cloud architect for a company?
Yeah, of course. Mike has core training. There's lots of training you can get on demand. But this kind of comes with a mix of training, good training from people you trust that are able to provide you with candid advice as in what you're getting right now into how you approach that career. And also, so you have to be kind of a continuous learner, and also your ability to kind of step out of your comfort zone and start working on cloud teams to work with architects and understand OJT, on the job training, how they do it well. So it's a mix of that. It's not necessarily a long journey. It's really someone who has a thirst for knowledge and a thirst for training. So someone who's a continuous learner, those are people I love to hire because they're going to scale it pretty quickly. This stuff changes all the time anyway. They're going to get the gist of what it takes to be a good architect. They're going to try to work with the best people in the business and gain and learn from them. They're going to gain as much experience as they can. They're going to step out of their comfort zone and take on jobs that they may not think they're going to be successful with, but believe me, you're going to have the capability of doing it. And that's going to build an architect. You're not going to be able to build it over time. In many instances, you have to go through a hierarchy of things. You have to go through development. You have to go through understand networking and things like that. But your willingness to learn, your willingness to have patience, your willingness to learn a great number of things, and have a humility of understanding that other people can teach you things always, that's going to be able to get you to an architecture level pretty quickly. I know a lot of people that get very initial anecdotal training and suddenly declare themselves as an architect, and they don't necessarily have the breadth of knowledge they need to be a good architect. They understand data centers, they don't understand databases, they may understand certain aspects of a particular cloud provider, and they may have a cloud architecture certification for a particular cloud provider. That doesn't make them an architect. So again, it's your ability to use gain a huge amount of experiences, learn a huge amount of things, have the humility for having people that are able to train you, and then try to align yourself with smart people that are able to take your career to the next level.
All right.
Love that response.
From Kuti. As an aspiring solutions architect, will employers value vendor-neutral certifications like CompTIA or the likes of AWS, GCP, and Azure?
Yeah, I think so. I would prefer those over someone who just has certification in a particular cloud brand, because that stuff's going to change pretty quickly. And so that training is going to become obsolete, even though the patterns are going to be the same. So someone who is taking the time to understand, generally speaking, how technology is configured, and I know that CompTIA stuff, because my courses are part of that, then your ability to get to the state, we're able to look at all different kinds of technology and understand what they do, like AWS, GCP, and Azure, is going to be a much easier thing to do. So you can go at it in multiple different directions, but I like the vendor neutral certification because it gets you away from thinking about the silos of the particular vendors. There's too many architects out there that just have AWS certification, just have GCP certification, just have Azure certification, and then everything looks like a nail. So, and they try to apply the same cloud over and over again for the wrong reasons, and that's never going to be the case, as we talked about earlier. It's absolutely, you think it's going to be a single solution that you can apply in each and every problem domain. Chances are you're going to get it to work with enough money and time. I can get anything to work, but chances are it's also going to be the wrong solution. It's going to be wasting the company's money.
I love the parallels.
I'm sorry, we're both all talking at the same time. Kuti, I want people to. I don't want people to be biased by certifications. Yeah. The first thing I do when I have someone that's certified, I said, "Forget this. Now we're going to start from the beginning. This is what this technology is. this is how this technology works. This is how this technology works in all clouds. Mm-hmm. Because it's enterprise architecture, we're going to ultimately develop a solution, and we're going to be vendor neutral. Now, at some point, we're going to get to the building block where we're going to swap out a virtual machine for a Google Compute Engine instance, an Azure Virtual Machine, an Oracle Virtual Machine, or an AWS EC2 instance. But it's all the same stuff. So the key is remembering, if you go to the Publix supermarket, the Aldi supermarket, or the Safeway supermarket to buy eggs, it's just eggs. So understand what all of it is, not the fancy marketing terms that are in some vendor certification. Because as an architect, we don't touch the technology anyway, we design it. So learn how that tech works and learn how it fits together and understand it really deeply.
Absolutely.
All right. Okay, now I've kind of reached a point where I'm debating on whether to cherry pick some questions to make sure we get to them, or if we just keep going in order. I'll let you guys tell me which one to do.
Whatever you want.
Whatever I want. All right. I don't normally do this, so that's why I was kind of debating about it. All right, so let me see here. There we go. From Robert. How accurate are Gartner and Forrester reports on cloud today? Any thoughts on Gartner's IT score and maturity level review?
Yep. Yeah, the reality,
we can be as short or as long as we want on this response.
Yeah, the reality is I consider all analysts' data in context with all the other analysts' data, and I kind of look for common patterns. So in other words, I never take any analyst data on their own merits and use it as the only source for decision making. So that's kind of the way. That's a very nice way to say that normally these things are going to reflect the needs of their clients, which are normally going to be the vendors out there, and so they may have some things that are going to be data that you don't necessarily want to follow. So you need to kind of understand that. So what I do look at is certainly the bigger vendors like Gartner, Forrester, but I also look at the GigaOms, which I work with for a while, and look at the other smaller boutique firms and look at their data and try to see where it agrees and where it doesn't agree, and then come up with my own conclusions as to where I think the actual market is and where people's are. I don't really look at the rankings in terms of different technology rankings by particular vendors because they have no idea what my problem domain is. They can't rank the technology with its viability of working with my particular architecture. We can look at the general viability via the criteria that they set up, and I've done those reports before, but you have to really kind of understand your own terms that you're dealing with and understanding the viability of the technology. So that's a long way to say you got to consider everybody's data, certainly read it, but you got to come to your own conclusions. You never take that stuff as gospel.
And I completely agree with David. Anybody can rank anything, but on what criteria? I have to evaluate as an architect what builds my client's business. What meets their business requirements best? And if it's an ICE machine or if it's a cloud, I'll pick whatever helps them the most. Whatever gives them the best return on their investment for whatever budget they have, because there's an opportunity cost. You can only invest your money in one place.
They cause some consternation for me because sometimes people come in there with those reports and say, this is the best cloud. And I kind of have to go through the way in which they can understand how that may or may not be the case, which just causes some additional work.
It's not new to tech. I used to practice internal medicine, and somebody would come in with the Ladies' Home Journal. I need this medication, the one in the advertisement. I'm like, whoa, let's take a step back. Let's figure out what's wrong with you first.
Right. Got to get test results.
Exactly.
All right. So Angelo asks, and Angelo is a great architect.
Excellent.
He asked, how have you used total cost of ownership to show cloud on-prem value of a proposed strategy or solution? What makes total cost of ownership more impactful in strategic discussions with leadership?
It's a great question. I think it's just one data point. So TCO, or the total cost of ownership, that we can figure out, based on the solution we're looking to move into. Certainly that's one data point. We have to look at the value that's coming back to the business. There's soft and hard values. In other words, hard values in terms of the cost savings that may occur by using this technology, but the soft values are the strategic values, where you get to the point Mike made a few minutes ago, the value of agility, the speed to grow, things like that you may get from a particular technology needs to be considered as well. So TCO is one thing, but it's one metric that you use with other metrics to make kind of a business decision core as to where you're looking to move into and what cloud architecture you're looking to move into. Use a multitude of them, because sometimes they'll agree and sometimes they won't. You can always ask the question, why didn't that agree? What assumptions are you making which may be incorrect? And are you considering a true model for TCO based on your understanding as the value that's going to be returned to the business? Or does this just get to a cost model? In other words, I'm just saving dollars in operational savings. That may be absolutely the wrong thing to look at. You need to look at the strategic value of the technology, as we mentioned earlier in the presentation, the value of innovation, the value to speed of market, all these sorts of things that are very difficult to assign dollars to, but you need to assign dollars to them because you may be missing the larger values.
And Angela, you've heard me say that I'm a finance professional, not an accountant. And what I mean by that is I have to build a business case and show the customer what this solution is going to do for their business. What does agility do for their business? What does automation do for their business? And do that and focus on that. Yes, total cost of ownership matters but what's it going to do for the company? If it costs them a lot and does a lot, it might be worth it. If it costs them $1 but delivers no value, it's an expensive waste of $1. So I like to start there first and then also include total cost of ownership. Angela is an incredible architect, and it's a great question.
Thank you, Angela.
All right, Daniel, got your question here. And I'm going to start it off with, reach out to Al. Al is on Slack. Al is a part of the Go Cloud Careers community. And Al did exactly what you're asking about here. What are the chances of someone getting hired at Deloitte who doesn't have real-world experience but has completed a course like Go Cloud Architects?
Give it a shot, because people who have the training, and if there's a need and you're talking to the right person and responding to the right job post, entry-level jobs or jobs out there with few experience are definitely possible at all consulting firms, including Deloitte. So never be afraid to apply for a job, and never be afraid to get training before you apply for the job. So getting training is key to the fact that we can see, or whoever the hiring manager can see, that you have an aspiration to get good at this particular career. And so in many instances, even though you lack some real world experience, they may give you a shot just because they're going to see what you can do and if they can build you into someone that's going to be more valuable to the firm.
And Daniel, Al Legister's first job at Deloitte was as a senior solutions architect. But Al was awesome. And Al had the last career was not in tech. He was a sales rep. And he had very good, exceptionally good customer facing skills. He worked hard and he did 700 hours in our training. So the key is, look, AWS has hired him. Deloitte's hired him. Capgemini's hired people with no experience. Accenture has, KPMG has, PricewaterhouseCoopers has, even Microsoft has. But you got to be great. You can't just take the training, get the training. You got to attend the training, do the work, and really work to be the best you can. Because as David said earlier, you can't find an architect. You just can't.
Yeah.
So when you find someone that's great and they're very emotional intelligent and they interview well and they speak well and they've got good leadership and good business acumen and they can design, now all of a sudden, well, they don't have experience, but we've got it in a university. It takes 3 months to train a new onboarder anyway. We can work with this person.
Yeah. And I'm reading Jermaine Houghton, one of our alumni that is working as an enterprise architect, sent me his talking points for his presentation at our conference. And the last talking point that he put is confidence is the key.
Yeah.
And this is a perfect example. If you've got the training and you've got the skills, you need to have the confidence, and that will carry you through if you're trying to get that job. If you don't have that confidence, it's going to come through during any interview. and it will pull it down no matter if you've got the skills and the competency.
Yeah.
If you don't have the competence, it's going to drag it down.
Yeah. Couldn't agree more.
So I thought that was, he sent that to me during the live stream. I was like, oh, well, confidence is key. That's a great point. Let me bring that up. All right. So a couple of more questions we're going to squeeze in here. From Telvon. We touched on this a little bit earlier, at least on one of these. What is needed more in the industry, network or security architects?
Wow.
Hit your heart with that one.
I'd love to hear Mike's answer on that. I'll give my answer, which I think they're both needed equally as much, and it won't work if you focus more on one versus the other. What do you think, Mike?
I completely agree with it. I think the more and more stuff is technology enabled, the more security people we need. And the more things that are technology enabled, if we don't have a network, we can't reach them anyway. So I don't think you can get away with either.
Yeah,
I think
both
the
are
key
well
Telvon
paying.
is to do what you really love.
Like
That's great
basically,
advice.
it's like pick an organ off your body. Which one's more important?
Yeah.
Anything you want to add on to that, David?
No, I think Mike gave the right answer, and I think that it's whatever one you have the most passion about. Both of those pay well, and it's whoever, and they're both needed.
Oh, yeah.
Yeah, that whatever you're passionate about, whatever you want to do, that going back to we give the it depends question 90% of the time. That's our answer.
Yeah.
It depends. It's because people come to us and ask us, well, what should I do? Well, it depends. Let's start off with, what do you want to do? What do you actually want to do? There's need for all of these. There's a necessity for all of these. And it just depends on what you're passionate about. What do you want to do? So, all right, I'm going to do this as our last question, and then I'll let you guys wrap it up. I thought this was a good one to end it on from Asias. Would you mind telling us about the books a little bit? An Insider's Guide to Cloud Computing and SOA convergence in your enterprise.
I don't like talking about myself, but I will in this instance. Insider's Guide to Cloud Computing is really kind of a tell-all book I just recently learned after spending 20 years in the cloud computing space. And believe it or not, I've been in that space for 20 years, as to what works, what doesn't, what you need to look out for, and the realities behind it. You know, how you figure everything we're talking about on this show, by the way, would be something that a topic for Insider's Guide to Cloud Computing, because I look at what's the pragmatic use of this technology, how do you use it, and kind of getting beyond the hype and a lot of the mythology that's out there in cloud computing. And so my clients asked me to write this book, and I went ahead and wrote it. And this is kind of a opportunity for people to spend $23 and figure out what the secrets of this industry is, kind of beyond what the hype is out there. Cloud computing and SOA convergence in your enterprise looks interesting. That was basically written in 2008 as we transitioned from service-oriented architecture into cloud computing. And the idea there was to look at the service-oriented architecture patterns and what the best practices were in service-oriented architecture and how those linked into cloud computing. So it's really kind of taking a service-oriented approach to how we're building and deploying cloud computing applications. If you look at what cloud computing is, it really is a huge service-oriented architecture. We're dealing with APIs and core services. We're dealing with abstraction, automation, orchestration, all these sorts of things, which are lessons learned, as Mike put earlier, basically are predecessors of, in this case, cloud computing technology. We built on that technology, in this case, service-oriented architecture, to really define what cloud computing is today. And the idea was to create a book that transitions people from understanding SOA, which was a big push in the late 90s, to cloud computing, which really kind of took over in the 2000s. And that's why I wrote the book.
And, you know, it's funny, Asias, in 2003, Cisco asked me to be the service-oriented network architecture guy and go train the engineers and architects on Cisco on that. Asias, about a month ago, Douglas is a student of mine and a friend of mine, comes to my house and he says, you got to read David's book. He says, you would like it. He sounds just like you. And I've read the book, Asias. It's a great book. I would highly recommend it. It really goes into the kind of things that real architects need to know.
Thank you.
All right. Well, I just want to apologize for anyone whose question I didn't get to. You all know I made a New Year's resolution way back in the beginning of January that we're actually going to stick to 2 hours on our shows. We're not going to do the 4.5-hour, 5-hour marathons that we used to do. I'm sure David appreciates that. I know my wife appreciates that. So we are going to wrap it up, and I'm going to go in clockwise rotation, I guess is what it is. I'm going to ask Alonzo if he wants to share any last thoughts. Then ask David, and then we'll let Mike close it out with our last thoughts. So, Alonzo.
Well, you know what? I had questions. I wanted to join in so bad, but I just said, let these gentlemen talk. Let me get this knowledge and just sit here. And I really enjoyed the flow of what's been happening. A lot of things about the architecture that I still need to solidify as a person who, with the cloud knowledge, it's never been a destination so much as a journey. So, David, I really appreciate you sharing this wisdom. Mike, of course, I appreciate you as well. I had an awesome time, and I will definitely not only be revisiting a lot of the concepts that I enjoy, but I'll be checking out your books as well, David. Thank you.
And also, I forgot to mention, I put the link for David's LinkedIn on all the platforms again in the chat box. So forgot to mention that. So
thank you,
David. Any last words from you?
Yeah, this is a great experience, and I think everybody should take away from it just kind of the thirst for knowledge, your ability to kind of understand that you're always going to be not understanding and gaining, and that this is going to be something that's going to be continuous. And that's what's great about this industry. It changes all the time. It's always going to be exciting and new, and your ability to make good sense of it and translate that technology into something that the business can consume is really what it's all about. And I hope you take out of here that you need to understand that learning is going to be part of that journey, and that has to be a big aspect of your career.
All right, Mike.
David, thank you so much for sharing your wealth of experience with us today. It's been really fun. I love talking to people like you that have been around in this industry for at least as long as I have, because there's not many of us, and we've been around, and I've enjoyed every moment of it. I know I've spoken to you. You had fun with it the entire way. This has been a lifelong love and journey for both of us. Thank you for sharing your wisdom. I know there's a lot of questions related to careers. I will come here tomorrow from 2 to 4 p.m., and I will answer any questions about cloud architecture careers. And on Thursday, we have a free webinar if you want to learn how to become an architect. And of course, there's that free guide on how to become an architect that lists everything, every technical skill and every business skill that you need. And whether you get it from us, you get it somewhere else, at least you'll know whatever you need to be an architect. Also, got to tell you, I really love David's book when I read it. You know, for less than $30 to get that kind of insight, I highly recommend it. I don't get paid a commission or anything for saying it. I just think it's a great book. And I love education. I love all the best educational tools. So I definitely want to say that. Thank you all for attending today. And look forward to seeing you all very soon. Take care, everyone. And thank you so much. Give me a hashtag cloud architect or cloud architecture in the chat box before you leave.
All right. Always wait until the last minute there, Mike. And for those of you that asked the name of the book, there's 17 of them, but I guess we're talking about the Insider's Guide to Cloud Computing, I believe. Absolutely. Is the one that we're referring to.
Yeah, not using Turbo C++. That's a bit dated.
Say that one again.
Not using Turbo C++. That's a bit dated.
All right. Well, thank you, everybody. We'll see you all again next week on Head in the Clouds. We'll see you tomorrow for the Q&A. And have a great afternoon.
Take care, everyone. Thanks for joining.